Good day, everyone. Today, in this particular video, I'm giving you some homework help to get you a little bit caught up to speed and together. Alright, so in this video, like I said, is to help you with homework. Alright, so we've been dealing with the unit circle so far. We've been working on it. We've been dealing with it so many ways. And we're almost done with the unit circle. So, let's go over a little bit about the unit circle. We know it's a circle that has a radius of 1, and the radius is also equal to the arc length of the circle. So we know what that is. All right, so here's the circle when we start drawing it. We worked with the 0, 90, 180, 270, 360 going all counterclockwise. So we did that. And we did our basic trig ratios building upon this, fact. So being r equals 1, and we build our trig ratios from there. I'll show you a picture of what that graph looks like when we did our trig ratios momentarily. And we know that tangent equals sine over cosine, but yet we haven't explained the y. That's going to be something that you're going to know for your test. So be prepared. All right, so with this unit circle, we start out with 0, 90, 180, 270, finding the trig ratios for those degrees. Then we talked about converting the degrees, 90, 180, 270, 360, these degrees into radians, which 180 has a radians of pi, 90 degrees have pi over 2. All right? And then we know that 0 and 360 has a radians of 2 pi. And that's for 0 and 360 has a radians of 2 pi. And it's only because they start and end at the same position. So that's why that happens for 0 and 360 degrees. But just keep in mind, when we're dealing with 2 pi, we always take it with 360 instead of 0. But just keep in mind that position, all right? All right. We learned some important facts about 30, 45, and 60. And we learned the radians forms of those unique degrees that are important to us. So make sure you have those understood by heart. All right, 30, 45, and 60. Those are very important angles to know. All right. So this piece of information, this is something we talked about today. A reference angle is the acute angle, acute being that it has to be theta, has to be less than 90. Can't equal 90 because if it does equal 90, that's a right angle, but acute less than 90. And it's formed between the terminal side and the angle of the x-axis as you see here. So that's how we talked about the acute angles, well, the reference angle. Again, the important angles that we refer to is 30, 45, and 60. Those are important. But getting back to the unit circle, why don't you? Our coordinate pair, x and y, has changed and become cosine being my x and y being my y value. All right. So sine, cosine, and tangent is based off these trig ratios. Now, the trig ratios of this unit circle, because now it changes just a little bit. So, like I said, cosine is my x, and sine is my y, and my hypotenuse is always forevermore 1. So, sine is y, cosine is x, tangent is going to be y over x. Now, today, you was introduced to the reciprocal trig functions or inverse trig functions. And these trig functions are cosecant. And when it comes to doing with the coordinate pair, like x and y, it's going to be 1 over y. Secant, which is the trig inverse of cosine, y over x. And tangent is the trig ratios of cotangent. Well, the inverse of that is x over y. Now, I wonder if you're watching this video, did you catch me in a mistake lying around somewhere when we was doing the lesson? We shall see. All right. So these are our point reference angles, and we did them to that in all 4 quadrants. All right. For example, we know we're in quadrant number 2. Trying to find where my pen is at. Let me change my color. That's why. In quadrant 2, a reference angle of 30 degrees. In quadrant 2, 150. Let me correct myself. 150 is a degree to have a reference angle of 130 because 180 minus 150 gives you 30. All right. In 45 degrees, you have an angle in quadrant number 2 of 135 degrees. That is a reference angle of 45 degrees because 180 minus 135 is 45. And for 60 degrees, in quadrant 2, you're going to get the reference angle of 120. 120 being your reference angle of 60 degrees because 180 minus 120 is 60 degrees. It is very imperative for you guys to pay close attention to that. All right. And again, reference angles must be acute angles. So when you add, subtract them, going through the quadrants, the angles have to be acute. Like 150 being a reference angle of 30, 135 is a reference angle of 45, and 120 is a reference angle of 60. And we subtract them in quadrant 2 from 180 because the angles are not going to be greater than 180. Now, in quadrant 3, you have a situation like this. In quadrant 3, a reference angle of 30 degrees in quadrant 3 is going to be 210. All right? Because 210 minus 180 is going to still give you 30 degrees. Again, acute angle. So that's how you do that. But for 45 degrees, there's going to be 225 degrees. And again, you know this because 225 minus 180 is going to give you 45 degrees. And again, acute angles. And then 60, when we go to 60 in quadrant 3, we're going to go for 240. And we're going to do 240 because 240 minus 180 gives you 60 degrees and it's an acute angle. Therefore, it is a reference angle. In quadrant 4, we have did things was different because in quadrant 4, to find a reference angle of 30 degrees in quadrant 4, you're going to take 360 because the maximum amount of angles is 360 minus 30. And again, I'm just taking that acute angle, which is the angle that's important to me, to be 330. And 330 has a reference angle of 30 degrees. All right. And then quadrant 4 for 45 degrees, doing the same math here instead of doing 360 minus 30, 360 minus 45. Because 45 is my reference angle. And that's going to give me 315. 315 has a reference angle of 45 degrees. And then here, for 60 degrees, in quadrant 4, I want to say 300. Because again, 360 minus 300 gives me my reference angle of 60 degrees. And that's how you do that. This is essential, highly essential for what you have to deal with for all the point and trig ratios. All right. So this triangle you see is a 30-degree triangle. Now, I have gave you the length of the sides of a 30-degree triangle. But before I go into this any further, I want to take you back to geometry right fast and right quick. So this could help you tie in what these lessons are coming from. So, if you had Miss Meyer last year for geometry, she went over the 30, 60, 90 triangle. And when she did that, she told you about the 30, 60. So 30 right here and 60 right here. So you're going to have the long leg, which will represent by the letter L. And that's always going to be square root 3 over 2. Square root 3. Sorry. Your short leg, which we call S, will always be 1. And then your hypotenuse, that always be your hypotenuse, that's going to be twice the short. So that's going to be H, which will be 2. So that's why in terms of the 30, 60, these numbers 1, 2, square root of 3 take place. So remember this. This is something that Ms. Meyer have taught you. It doesn't matter when it comes to 36 triangle. These are the leg amount. Let me highlight these better. Oh, I almost did it in black. Square root 3, square root 1, 1 and 2. This is what Ms. Myers did for you guys with the triangles. All right. And then when we're going to get to that later. So with that being said, now, this is what the 30-degree triangle looks like. The numbers are still the same as 30, 60, but because my long leg, which I will use the letter L, is going to be right here. This is the square root of 3. And then the short leg is 1. The hypotenuse is going to be 2. Now we did our basic trig ratios, sine being 1 over 2. And again, this is for 30 degrees. Cosine being square root 3 over 2. and my tangent being 1 square root of 3, which we know cannot ever happen because you got square root of 3 in the denominator, so you have to rationalize your denominator, which you know multiply everything by the square root of 3 on both sides. And when you do that, you get square root 3 in the numerator and then square root 9 in your denominator. But you can simplify 9. The square root of 9 is just 3. And then your numerator was the square root of 3. So we did this. So one thing you gotta remember, if it's a square root of 3, if it has a 1 in the numerator, your answer is gonna look just like this. So square root at the top or basic 3 in the denominator. Alright? That's all you really need to master down. This step right here, make sure you know how you know this step and you could explain it. But the final product is going to be this right here. So make sure you know what to do. Alright, so that was sine, cosine, tangent of square root of 30 degrees. Alright? This triangle right here was 45 degrees. So 1 square root of 2. And let me bring you back a little bit before we go further. Going back to your geometry. Your triangle. Your legs are equal to each other. So this leg will be 1 always. This leg will be 1. And then this will be square root of 2. So 1, 1, 2. And that's for a 45. 90-degree triangle. And if you need that, I will post an additional video of that too. Alright. So let's do this. So we know sine of 45 degrees. Let me write down 45 right here so you know I'm in 45 degrees. The 45 degrees triangle for sine is 1 square root 2, but which you know cannot ever happen. And you should know multiply everything by square root of 2. And 1 times square root of 2 is just simply just square root of 2, because 1 multiplied by anything is that anything. So square root 2 in your numerator, 2 times 2, because they both are square root, is square root of 4. And you know the square root of 4 is going to be 2 in your denominator, and then square root 2 in your numerator. Alright? And we know that cosine is going to be the same thing. Well, before I do that, you know cosine is going to be 1 over square root 2. And your answer is ultimately going to be the same thing. And your tangent is simply just going to be 1 over 1, which is just 1. That's that. Alright. Now, let's talk about those inverses already. Alright. So we have inverses like, for example, cosecant, which is CSC, is the inverse of sine. So instead of saying opposite over hypotenuse, you're going to say hypotenuse over opposite, which is square root 2 over 1, which is simply just square root of 2. Secant is the inverse of cosine. So instead of you saying adjacent over hypotenuse, you're going to say hypotenuse over adjacent, which is going to be the same thing, square root 2 as your 2, square root 2 over 1, which is just square root 2, and then cotangent being your inverse is going to be, instead of you saying opposite over adjacent, you're going to say adjacent over opposite, and that's going to be still 1 over 1, which is just 1 still. Alright, so those are the trig ratios of what we did. Alright. I think you guys got it from right here. Now, there is some warning that I want you guys to be advised of, something that I want you to take good note of. I'm erasing this for a reason. So say for example, I give you 2 square root 3. This is something that I need for you guys to get a good understanding of. So, you guys do well with multiplying everything by the square root of 3. Okay, you do this part really good. But here's the issue that I deal with when you finalize this. You get square root 6 over 3. Because you multiply 2 times 3 to give you 6. This is a no, no, don't do it. No, don't do it. So, it's because you cannot multiply 2 times the square root of 3. You can't do that. Because when you do, it's just going to be 2 times square root of 3. You know? You go 2 plus square root of 3. Guess what? You can't do that either because that's going to be 2 plus square root of 3. You know? So you're not allowed to do those particular things. Now let's show us how to do the correct way of this. Alright. So, it's how you're going to multiply 2 times 3. 2 times square root of 3. You should have something like this when you multiply them both. So your numerator is going to be 2 square root 3, and your denominator is simply just going to be 3. You can't simplify that part. You can't simplify this because 2/3 is just 2/3. Alright, good. This is a 63-degree triangle, and this is square root 3, 1, and 2. And we know sine is square root 3 over 2. Cosine is going to be 1/2. And tangent is just the square root of 3 for 60 degrees. Now, I'm not going to do the 3 trig inverse ratios. You're going to do that yourself. So I encourage you to pause this video and just go on and practice those inverse trig ratios. All right. So these are your old trig ratios that you knew before you met Miss Myers. When you met Miss Meyer. And then the ones that I taught you, given a coordinate pair. All right, your new trig ratios, like I told you guys, is cosecant, secant, and cotangent. And of course, I always give you the opportunity to flex your mathematical muscle. So catch me in the ad if you want to. Post a comment. I just want you to see. I just want to see who could catch me. So cosecant, secant, cotangent. When you're given, just the size of a triangle. But when you're given the coordinate pairs, you're just going to do 1 over this, 1 over that, 1 over, then you're going to just take the multiplicative inverse of tangent, which just flip things over. All right, so after today, we have known everything about the unit circle, so our unit circle skills should be together. So remember, cosine is x, sine is y, and tangent is going to be sine over cosine. But if I was to ask for cotangent, cotangent would be cosine over sine. That'd be cotangent right here. So again, by now we should have this unit circle together. All right, pay attention to the quadrants. Your quadrant knowledge is very important because, again, going back to your knowledge of your coordinate pair in the unit circle, cosine and sine. So in the first quadrant, everything's positive, even tangent, because tangent again is sine over cosine. So as long as you got no negatives here or here, tangent is going to be positive always. Now at quadrant 2, tan is negative because sine is negative. As long as you have a negative when you are dividing, you're going to have your answer be negative, so tangent is negative at quadrant 2. But sine, well, let me fix myself. It's cosine right here. So cosine should be negative, not sine. Cosine is negative. All right. In tangent, both, since sine and cosine are both negative, tangent is positive because when you divide a negative by a negative, it's positive. All right. So in the class, we did an example like this. 5 power over 4, and I taught you what to do with it. Now, for starters, look at your denominator. You know for a fact because your denominator is 4, your reference angle is 45 degrees. So I'm not going to do sine, cosine, and tangent. I'm going to do sine, but I'm not going to do cosine, and I'm not going to do tangent in this video. You're going to try that out or do it in the homework problem. So some of your homework is going to have questions like this. So to do that, power over 4 is going to become 45 degrees. And we know sine of 45 degrees by what we did is going to be square root 2 over 2. So we know that. Now the question is it positive or negative? So now you're going to convert 5 pi over 4 into degrees so you can know your quadrant, so you can know if sine is positive or negative. So multiply this by 180 over pi. You know your pi is going to cancel. So 5 times 180, when you multiply that, that is 900. Divide that by 4, that's going to be 225. And we know at 225, everything is negative except tangent because, and I say this because 225 is in quadrant 3. So everything is negative but tangent. So sine of 45 degrees is going to be negative square root 2 over 2. So that's how you do that. And this is just an example of what they did. So they drew a picture, and the textbook just assumed that you knew that, 5 power 4 was in quadrant 3. So it assumes that you know all of this. And then I gave you that chart. And then it tells you sine of 45 degrees is square root 2 over 2. So this is just knowledge of that. So, and they did tension, a bit different than how I would do it. Because they used the coordinate pair. They took this coordinate pair and they divided, which gives you positive 1. Of course, I would have just stuck with the 30, 45, and 60 because those are important. Once you got those memorized, that's easy. So I did it one way. The textbook kind of did it a little bit different, but we still got the same answer for tangent. All right, you do 330. I'm not doing that for you. Oh, here you are. So again, you know, 330 is in quadrant 4. And I know my reference angle of 330 is 30 degrees. Or if I want to go the other way, it's pi over 6. So use my knowledge of a 30-degree triangle. I did that. I did all of that. Now the question is, which is positive, which is negative? Because sine in quadrant 4 is negative. So that means my tangent is going to be negative 2. So cosine would be the only one that's positive. So sine and tangent is negative. So that's how I was able to figure things out. For that, again, this is your textbooks doing. So it looks like we were doing the same exact things. All right, I'm not doing this one. I want you to figure this one out on your own. This is similar to what we did in class and what I just did in the example. Well, there you are right there. Again, we realize that 2 power 3, you get a reference angle of 60 degrees. Your textbook assumed that you knew that 2 power 3 is in quadrant 2. I personally wouldn't go down like that. I would just convert the radians to degrees and just keep it going to figure out where my quadrant's at. And since I know looking at the 3 in the denominator, I know that my reference angle is 60 degrees. So I should go for what I know about my sine, cosine, tangent of 60 degrees, which they did that too. I just knew quadrant 2 cosine was negative. So that's how I'm able to figure this out. All right, we talked about our reciprocals. And they just, did a reciprocal things that of 30 degrees. So that's what they did here in this example. All right, this last piece, this is the challenge piece, and then after that, we should be good. All right, so then I want you to prove your trig identity of sine squared plus cosine squared equals 1. I personally will be addressing this in class because now my time is a little short. All right, so I know we did not talk about this in class. However, it is on your homework. I do want you to try this out. Now, I'm going to show you 2 ways of doing this. The new way that I didn't talk about, but I'm telling you now in this video. Now, using your Pythagorean identity, sine squared plus cosine squared equals 1. So, I know you said Pythagorean theorem for your 10th grade. Now, because you are in 11th grade, you say your Pythagorean identity when you using the unit circle. Sine squared plus cosine squared equals 1. So this is something that is going to be very much so critical for us. All right. So here's the question that asks us: what is sine theta and tan theta if cosine is negative 3/5 and the terminal side of theta is in quadrant number 3? So what is it telling us to do? Find sine theta and tangent of theta. All right. And then our given, we have, we have cosine of theta being negative 3/5 and is in quadrant number 3. Or the terminal side of theta is in quadrant 3. All right. So to do a problem like this, first and foremost, you're going to take care of this problem like it's a Pythagorean theorem. So go back to remember how you did things with the Pythagorean theorem. Now you're going to use the Pythagorean identity. So what's given here is cosine of negative 3/5. So sine squared plus negative 3/5, and we substitute that for cosine, equals 1. All right, when you square the negative 3/5, it's going to be 9/25. All right, when you subtract 1 from it, so 9/5, 1 minus 9/25, you get 16/25. All right, square root that on both sides. When you square root that on both sides, you're going to get plus or minus 4/5. Now remember, in the beginning of the school year, I have taught you that when you're dealing with a exponent of 2 or more, they're going to tell you what kind of answers you have. But because this is an exponent of 2, you're going to have plus or minus 4/5. Now, we do know, because it's in quadrant 3, we know this in quadrant 3. Sine is negative. So because sine is negative, we're going to take it as negative 4/5. Now, tangent, because that's what it was asking us to do. Tangent is going to be sine theta over cosine theta. So, sine was negative 4/5 because you're in quadrant 3, everything's negative. So let me write this down right here so you can see. Sine theta is negative 4/5 only because I am in quadrant 3. The only thing that's positive is going to be tangent. So when you divide sine and the cosine, of course, you could put this situation in decimals if you want to. And when you simplify it in decimals, you will get 4/3. But for those who want to see to do this by hand, so 4/5, I know that my answer is going to be positive, so I personally just going to remove the negatives because I know when you divide two negatives, it's a positive. So I'm just going to divide with positive. So keep 4/5, change the division to multiplication, and reciprocal into 5/3. So 3/5 will be reciprocated as 5/3. Again, I got rid of the negatives since both of these, since two negatives makes a positive. So 4/5, I turned to positive because I had two negatives, times, because I changed multiplication to division, 5/3 because I flipped them forward. I took the reciprocal of 3/5. So when you multiply, your 5's cancel out and it's going to be 4/3. And we know that in tangent everything's positive. So since the angle is in quadrant 3, y coordinate sine must be negative, therefore sine is negative 4/5, and tangent is going to be positive 4/3. So that's how you do this problem. Now, just to have fun, I want to try this using the basic Pythagorean. So suppose I'm trying to erase this. I want you to do this with me and see what happens. So I erase this, and I'm trying to find sine equals sine and tangent, and cosine is negative 3/5. I wonder what will happen. So this may be something I may ask you on the question. I may be student B, and I may work the problem out, and you may have to, grade me on my work. So I'm gonna be student B right now. So I decided, Miss Tara, I'm just gonna stick with the Pythagorean. I don't want to do, the Pythagorean theorem. I don't want to do the Pythagorean identity. So I'm gonna just do it my way. We're gonna see what happens. So let's see what happens. So I do know that cosine is going to be 3/5, right? So cosine, based on my trig ratios, opposite, adjacent, hypotenuse. So I know I'm going to have 3, and then I'm going to have 5 right here. So that's my trig ratio. Now, what I want to do, for the time being, I don't want to use the negative sign. I'm not going to. So it's just going to be 3/5. So I wonder what happens if I use my basic Pythagorean. A squared plus b squared equals c squared. Again, I'm not using no negatives. I'm not doing a negative 3/5. I'm just going to use 3 and 5. So I know that my hypotenuse is going to be 5 squared. I know my I don't know what my a squared is, but I know my b squared is to be 3 squared. All right, so I know my a squared is 9. Well, my b squared is 9, and my c squared is 25. So from there, why did I not subtract 9 from both sides? So a squared being 16. But a, if I square root both sides, a is going to be 4. So I'm going to call my opposite of that to be 4. So I got 4, 3, and 5. Now, again, I'm not paying attention to that negative sign for this right here. I'm not paying attention to this at the moment. No. I want to explore and see what happened because I'm student B. My favorite teacher, Miss Meyer, who was so awesome and taught me the Pythagorean so well, that's all I want to stick to. So I want to see, can this work for me? So with that being said, I know sine. Now I should be able to find sine. Sine is 4/5. And tangent is going to be 4/3. Okay, so I did the work. but I am missing some detail. But I don't think I'm right. I don't think I'm wrong though. I think I'm right. Sine is 4/5 and tangent is 4/3. So in the comments, I want you guys to call out something. So was I 100% correct? Was I somewhat correct? Call out what am I missing? Now, on your quiz, I'm gonna do a part. What you see in this video is what I'm gonna question you about. So I stuck with the basic Pythagorean. I realized that I got sine to be 4/5 and tangent to be 4/3. I did not use the Pythagorean identity. I did not pay attention to cosine being -3/5. I'm also missing the fact about about this being in quadrant 3. So you should recognize that most of this is correct. The only thing that I would say that I would lose points on as a student is not paying attention to the fact that I'm in quadrant 3. So I could use the basic trig ratios, which I did. That's fine, but quadrant 3 is important, and that negative sign for cosine is important too. Because in quadrant 3, something is negative, which you're going to find out, and something is always positive. So go back to quadrant 3, what's negative, what's positive, and that should tell you about what I did wrong. Alright, y'all. Good luck studying.